So in this video, we're going to take a look at how we can construct a project that has multiple files. Because ideally, we want to be able to separate out things into multiple files rather than having it all in one big file because it makes it easier to maintain our projects. So let's take a look at a really simple example. Suppose I wanted to create a program that was able to take the sum of two numbers, and I'm just going to hard code them in for now just to keep things really simple. And then we want to print out that sum, right? So something along the lines of this. Now in this sort of situation, we of course would need to create the add function. But let's go ahead and make that in a different file and see how we can connect it into this main start.c file. So the way that we would go about doing this is first we would create the file that contains the function. So I'm going to call that add.c. And I'm going to have int sum. It takes in two numbers. And it returns the result of adding those two numbers together. And that's all our function is. Now at this point, we have the function implemented in one file, and then we have a file that calls that function. Now, one of the questions that you may have is, if you remember when we talked about function declarations, we talked about this idea of implicit versus explicit declarations of functions. And we said that when we're working in C, we want to provide some context about the actual function itself, doing something like this, where we tell it the return type, and we tell it the parameters that that function should take in to give the compiler all of that context. Now, the question is, when we have multiple files, where do we put that sort of declaration? Do we put it here in the start.c, the thing that's calling the function, or do we put it here inside of the function that is, or inside of the file that's actually declaring the function? And the answer is really, the best practice is actually to put it in a third file, which is known as a header file. A header file in C provides a lot of context to the compiler about the things that are contained within the actual implementation file. So in this example, add.c has the implementation, so the actual implementation of the function itself. And then it will have a corresponding header file that has all of those explicit declarations. So things like telling us the return type and parameters of the function. And then what happens is when we want to call that function, we simply import the header, which is what we're actually doing here with stdio.h is a header file. And what the compiler is able to do is it's able to get just that stub and say, okay, that's the return type and those are the parameters that we provide in, and that's the function that's being used, so it can understand how this function is being called. And then it can go and find the implementation to actually use it when the function is actually run in the application itself. That's the general idea of what we're doing with headers. So to create a header file, we just simply create a file and it has the extension .h. And inside of this header file, we can just type in the function declaration like we would have done in the previous videos where we were declaring the function in the same file. So we have int, and the function name is sum. And then in brackets, it takes in two integer values like this. So that's all our header file is. And then what we do is we come over here into this implementation, and we add an include for add.h, which is the header file we just created. This way, when C takes a look at this function, it's able to understand that that header, this implementation here, corresponds with this here. So you see that it kind of links those two together, giving us the actual declaration and then the implementation. And then similarly here, we need to be able to tell it what this add function is. So once again, we say, okay, we'll include add.h. That gives it the header file, so now we can look and say, oh, okay, so there's this sum function, and I realized that I named these different. This I've named add, and over here I've named it sum, so let's just keep that consistent, and we'll call this add. Let's make sure that I have this as add as well. Yeah, so we'll call this add as well, just to keep it all consistent. So now it's able to see that this add function here is in this header file here, and then it can come over to this implementation, and it can use this implementation to run the actual code itself. So that's generally the way that all these files are connected together, is using this header file. Now, when we come down to actually compiling the code, what we do is the following. We say gcc, and then we give it all of the files. So add.c, add.h, and start.c. And then we compile it into a single binary output, which I'm going to call start. So it gets all those files, it compiles them all together, makes all the references and links them all together and gives us this single binary file. And when we run that single binary, it gives us the result. And that's the result that we were expecting. If we add 2 and 3, we should have gotten 5. And that's exactly what we got. So you can see that that gives us the way of being able to compile these files together into one main file. And this is something that we're going to see frequently as we're working in C. So you'll continue to see this type of idea of working with headers and some of the other things that we might be able to add into these different header files. So thanks so much for watching this video. In the next video, we're going to talk a bit about makefiles to show you a bit of an easier way of being able to set up the compilation of these types of projects. Because of course, having to put in every single file gets very tedious if you have a lot of files to put together. So I'll show you some tricks for using makefiles for that in the next video. So thanks so much for watching. I'll see you in the next one.